So welcome everybody to this March 2021 meetup, organized as every time by .NET Devs AT. Who are we? First, thank you all for joining uh, on this Tuesday afternoon. Um, Meetup is organized by .NET Devs AT. We are a non-profit organization here in Vienna, Austria, that's about sharing knowledge about .NET development with as much people as possible. We have a website. We are on Twitter. I quickly share these links all with you. We are on Twitch, as you know, because you're looking, viewing at, yeah, watching us. That's the word. We record everything, and the recordings go up on our YouTube channel, and we have also a Slack channel where we help each other out. So I put the links all in the chat. Um, we got sponsored, and thanks to our sponsor, that makes it possible to organize these events and everything around. Thanks. I should switch in OBS the scene, so now you can see the picture. So right for the sponsors. So thanks for OBS Software Services, Tieto Every, and Rubicon for sponsoring our meetup. Also thanks for JetBrains. JetBrains is sponsoring one 12 months product license. We are raffling them, and at the end of the meetup I share a feedback link with you, and if you fill this out, you're in the pool, and then you get the chance to win this license. Some quick news from the community before we go to the main talk. We are part of the .NET Foundation virtual user group. It's a virtual user group where you can find a lot of meetups that happens around the world, as they're all online now. Yeah, you're also there, and there are a lot of other stuff there. So join them to find other cool meetups around the world. For the Austrian viewers interesting, Microsoft is still doing their cloud transformation workshops. There are new dates there available, and check them out. They are free. I think there are multiple day workshops about all Azure stuff and so and go on. Yeah, there. Yeah, and there we're already at our main talk today. So on our talk today, it's embracing gRPC in .NET by Irina. Irina, thank you for joining us, and it is your stage now.
Thank you for inviting me. Hello, everyone. Today we're going to talk about gRPC. gRPC is not a new subject, but I'm pretty sure no one still uses it in production. And because I have a personal vendetta against people that are not coding APIs as they should, I'm trying to present you an alternative to REST API. So who am I? First of all, my name is Irina Scurtu. I come from Romania, in a city called Iași. I'm a software architect at the company Endava. I'm a Microsoft MVP for developer technologies, which means that I'm pretty much passionate about everything that is new around .NET, of course. I teach .NET and I blog from time to time, not often, as often as I'd like. But today I'm going to try to convince you that if you're not doing REST properly, maybe you should have a look at gRPC and try it in your apps. So first of all, we cannot talk about distributed systems without remembering where we started. We all started with monoliths. I mean, you have to admit, at least in my case, I used to love monoliths because it's very easy to start with. When you're a junior, for example, everything that you need in your code is there. If you need an instance of something, you go ahead and grab that instance and everything, poof, works, right? So you have a single code base for everything. You do not have to worry about separate pieces scattered everywhere. There is no Kubernetes involved or other technologies like that sometimes makes a developer's life not easy. But with the monolith, there are a few problems. It's kind of hard to scale, and that scalability comes with a cost. And usually that cost is not directly proportional with the income that you're getting from your product. And often you have bad user experience. But and I also remember a time when I had a big solution, and every time I wanted to build that solution, I could go ahead and grab a coffee because it took so long. And another thing with the monolith is that, well, when you deploy the monolith, it's kind of all or nothing. You can deploy and everything will work, or nothing will work if you do not have the proper system in place to do red-green deploys. But it was nice. I mean, I remember the time. So, for example, when I first started, there was ASP Web Forms. There was ASP MVC, I think, MVC version 2 or something. It was 10 years ago at least. And the architecture, quote unquote, kind of looked like that. You had the front end and the back end in the same application. You used one database or several databases, and everything was self-contained in a single block. You rendered the front end from the server side, you push JavaScript from the server side, and everything just worked. But now the paradigm is kind of changing. Now we have a front-end app, and we have back-end, and we have a database or several databases. Why do we have these? Why do we accept to have these moving pieces? Well, because usually it's easier to manage, and we want to be agile. We want to deploy faster. We want to develop and deploy faster, and having smaller pieces makes this possible. If, for example, you want to deploy a part of your app that is very often changed 10 times a day, you can do that without, I don't know, maybe affecting your clients or your customers. But with a monolith, you kind of couldn't do that because you needed a lot of time to prepare. But we need to embrace the fact that the future is distributed, and it will be. And now we have a front end that communicates with several backends or backend APIs, and in their turn, those backends communicate with maybe third-party APIs, server-to-server calls, and each they have their databases. Or if you move one step further, then you might have micro front ends that integrates in a big client app, but they're independent apps. So, because the modern times and the times that we're living are changing, and we have more data, and we need to process that data very fast, and we need to respond to the customer needs, then we might need to have a system that is not only one language, that is not only C#, and we shouldn't have maybe NuGet packages to share code. Maybe we need to communicate with the Go API, and that Go API communicate with Node.js or third parties, and it pretty much shouldn't matter what is the language. And now you might say, okay, but where's the problem? We have JSON. The JSON file, or the response, or the request in the JSON format is a common ground for absolutely every API, no matter the language or platform that is written in. And I would say, yes, we have JSON. And because we have JSON, it's somehow implied that, well, we have REST for everything, right? Admit it. When you're saying you're doing an API, you somehow imply that you have REST APIs. I admit, I used to do that. When people or junior developers or not so junior developers are talking about APIs, the backends for the front ends, it's self-implicable somehow that API is REST, representational state transfer. When in fact, if we were to look deeper, those APIs are just JSON over HTTP, not REST in the true meaning of the REST architecture. So now, usually you have client and server, right? You have a client app and you have a server, and in between there is a request and the response. And what happens with the classical communication, like client to server, is there is a process called content negotiation. And the content negotiation process, it's about the format of the request, the payload, the error handling, and the retries, and how do you handle those? And maybe it's about authentication. And also, when you have client to server calls, you need to worry and think, what happens if the model changes? In the client app, okay, the client app will break, right? But what if you have server to server communication? Because we often do. We often, when we switch and move on and say we're having microservices architecture, we tend to choose microservices. And in those microservices, we will have server to server calls to bring data over. There's the talk that, well, microservices, independence, self-isolation, single database per microservice, and so on. But, well, what happens is that we sometimes need to bring data over. And to do that, we tend to use HTTP client requests, in .NET at least. So you might ask, okay, still, what's wrong with REST? It works. You can do API to API call using an HTTP client and everything will just be fine, right? But in REST, there is this chit chat that will happen with inside the teams. If something changes in one API, you'll need to go to the other team and talk, hey, bring the other fields over or remove this field because it's not used anymore. And there is also another problem. We often do not trim and design the APIs constantly. We start from scratch, you design the API, you develop the API, but that API evolves, and evolving, we won't look over them, those APIs, and we won't remove the unnecessary fields because the business changes, the business needs change, and then we will need to trim constantly those APIs. And that's why sometimes people say, hey, REST is not a solution, go with GraphQL, because GraphQL brings less data and it doesn't have the problems REST have. But REST, it still has a few problems, and the data that is carrying over and the chit chat that is forcing us to do in the teams, it's one of those problems. It's not that I'm not encouraging you to communicate. I do encourage you to communicate, but sometimes you need to be that fast and to have a way of not talking with the other teams because you need to deliver fast, and just showstopper sometimes. So let's have a look at what a RPC, or a remote procedure call, is and how it can improve our life as developers. So RPC is there, I don't know, maybe from the 60s. It's an old concept that tends to resurface from time to time. And RPC, I will want you to look at some code. We have here a variable called order that is gets the value from a create order from somewhere, a payment status, and then we need to check if the payment status is successful. Then we need to arrange the shipping for it. And that's it. If you have a look at this, it seems pretty local. If you're thinking and you're considering yourself in the context of a monolith, you'll see, well, this kind of looks local. There is no network involved. They're just method calls from different services or different contexts. And that's it. Well, what if I told you that the payment process it still involves a network? Because the RPC is what it does. It makes the network communication transparent. It forces you to overlook that. It's like it's not there. For you, calling this is something that is so familiar and it's so code-like that you will forget that there is a network in there. What will happen is that sometimes RPC is prone to errors if you're not using it wisely. And its main goal is that? Just to make network communication transparent. Somehow people thought that what if we would have a distributed system that pretty much behaves like monolith? What cool would be, right? So they invented somehow RPC. But still, what is gRPC? Because that's the main reason we're here and we're talking about. So gRPC is there for a long time. It started in 2001 at being the Google Stabic internal project. And a few years later, they open sourced that. But only in 2016, we have the gRPC v1 that is usable. And in 2019, we have gRPC with .NET Core. So gRPC as a whole concept will still make the network communication transparent with a twist because it's contract based. And also you'll have no code references. For example, I've seen projects where people are sharing HTTP clients between projects, between APIs, for example, through Nugget packages because, right? Why not? Make a Nugget package, share that wherever is needed, use that package. But the problem is those Nugget packages kind of tend to be crowded and to gain more knowledge than they should have and to have business logic. And they're not just HTTP clients anymore. And that's a bad thing because as microservices states, those should be independent. And when you add code reference, well, here goes your independence. So another thing with no code references that is very cool is that you'll see in gRPC, we have one file that you'll be able to share, but you'll have no code references. Another thing very cool about gRPC is that it uses HTTP2 by default. And by using that, because of the way that it's built, is way faster. And top that with some super cool efficient protobuf serialization, which will end up having a smaller payload. And another thing is that is available in many languages, allowing you several ways of distributing code and talking with different APIs, having this common ground, the file that I was mentioning. And also, it will do some code generation for you. So having all these, I think it really worth looking at. So if we were to compare what we also had before, a client or being an API or service, it doesn't matter, we will have something in between them. And in that in between them is the proto file. And the proto file it's just a file with the proto extension that has a specific syntax that is defined by Google. And let's have a look. So the proto file is the core of the gRPC pretty much. And first of all, when you're creating such a file, you need to define the version of the syntax pretty much for the file. And in here we have the syntax that we're using, proto 3, so the version 3 of the proto syntax. And then you'll need to specify which is the namespace, which is the package. And after that, you go ahead and define what are your services that you're exposing. What is your interface definition, pretty much. So you go there and specify this by using a few keywords like RPC. This is a method. You're saying that this is an RPC method that I'm trying to expose. And then I have my service that is called Fibo from Fibonacci. And then my method is called compute Fibonacci. And it has as an input something that is called requested number and returns a Fibonacci result type. And that's it. You just saying, okay, here is the method that some service that has access to my file will be able to process. And what is the message request and the types that I'm receiving as an input, as a parameter and as return type. They're nothing more than just typed, defined in the proto syntax with the keyword message and the type that you're defining as a simple class, for example. And as a body, you will have properties. We call them properties, but they're pretty much, this will be transformed in C# properties. We have int32 as being the primary type in Proto. And in here, you'll see an equal one that I'm going to tell you it's not an assignment. It's being a binary serialization. It's the order of that field inside this type to help the serialization and deserialization happen. So if you would have, I don't know, several, you'll have, for example, 2 and so on, but it's not an assignment. So having all these, you'll have a complete file that you'll be able to expose to your consuming APIs or clients. So, okay, we have the proto file, we have the syntax, and we have some primitive things, but the power of gRPC, besides the fastness and besides the serialization and the everything, are the types, or let's call them modes or methods and so on. So these are pretty much, you'll find the different terminology depending on the context, but they're types of calling somehow. So the first one is unary, which is similar to what we know from HTTP clients as being request response. So one input, one output as comparison. The second one is the server streaming, where the client initiates a request and the server will stream several responses. Client streaming, which is the reverse, and of course, bi-directional, which is somehow a combination of the previous two. Okay, how they look, and you will see this. So client server, request response, the typical manner. A client initiates a request, the server receives that request and sends back a response. How it looks? Well, it looks pretty much like in the example I showed you in the proto file. To define such an operation, you'll have the in and the return type. This shouldn't be here. And you have a Fibonacci result, and that's it. And server streaming, the next option, still the client will initiate a request, but the server will send several pieces back. Okay, so one in, several outs. And client streaming is the reverse, where the same, the client is the one initiating the communication, the server processes the request and sends something. So the client sends several pieces of as part of a request, but it receives only one thing back. So it's the other way around. When the bidirectional part is a combination of the two, still the client is the one initiating the communication by sending several things in, and it will receive several things out. One thing that I would like to have a look at is this stream keyword that depends on where it's added, it gives the type of operation. So if we add here as being in the parameter, as in parameter, you'll see that, okay, compute Fibonacci, my method, will receive a stream of this type and will return a stream of that type. And in this case, we defined a bidirectional communication. If we would have like only here the stream, but only one thing out, it would be the client streaming. And in the other way around, it would be one thing in and a stream of out, right? Okay, but enough with the talking. Let's go and have a look at the code. Okay, first of all, how to get started and what do you do to obtain such a gRPC project? Well, first of all, you'll have to open a Visual Studio instance. Hopefully my computer won't die for whatever reason. And you'll need to create a new project. And from the project templates, you will find gRPC. We will find when this will load. Okay. So we already have a template gRPC service. As you see, it's cross-platform. It doesn't matter the platform you're using. You're clicking next. You give it a name. And as next part, you should be able to choose what is the version of .NET that you want. I'm gonna go with .NET 5 because it has a lot of improvements in gRPC, but it's still the same project template. You just click create because we do not care about authorizations or other things. And what I want to show you is that even if it's gRPC service, a lot of these projects we are already familiar with. It's nothing new. So I will try to zoom in a bit if Visual Studio lets me. So we will see that come on, help me out there. So you'll see here in the right-hand side under Solution Explorer that we're seeing a few familiar things. We're seeing the startup, the program CS, and the app setting JSON, which means that at its base, it's still an application that we're familiar with. If you work with the web API, you've seen these things. So another thing to look at is that in startup, there is already a thing configured for you. There is a middleware added. I'm going to increase this. So there is a middleware with a gRPC that will do the job for you. You'll have to do absolutely nothing with it. It will have, and pretty much this is it. The rest it's super familiar. Also, you'll see that in app settings, it's the same. It uses Kestrel with the endpoint default, but in fact, it uses as a default the HTTP2 protocol. And pretty much so far, so good. This is it. What happens is the magic that you'll find in the proto file. And this is the template that I pretty much showed you. What it does is specifying that you have a service, just like you would do, for example, in an interface. When you define in C# an interface, you would say, hey, this is the interface, this is what I'm exposing, this is the contract for you, this is what you have to implement. So exactly what happens here. You have this file that you'll be able to share between your projects, and this file will be the contract, okay? It's up to you to give the implementation. So it defines a say hello method that is unary because it doesn't have the stream keywords, not here and not here also. So it's request a response. And given this, we're pretty much set up to go, and not without telling that, hey, I have this file, but I also need to give an implementation for it. So what you'll have is a service, and that service will be the one that will actually contain implementation for what you specified in the interface definition. So Gritter service, and this part, gritter.gritterbase, it's something that is code generated, it's automatically done for you. So it's done for you in the process of build. So starting with this, so Gritter, right? You will have a base automatically generated. And if we were to explore this base, you'll see that is a public abstract partial class. Have you seen that before? I didn't. Called Gritter base, and it has all kind of strange code in here. But what it does is creating you the core for what you need. So
Irina, one short interruption. We have some technical problems. The stream is about 1 minute between image and audio, so I quickly have to restart the stream. Give me a moment, please.
Okay.
So
I will try to hold my thought to go on from where I am.
So it's still stopping. Stopping stream. What is taking so long?
This is from my part or your part?
No. it's
did I close something?
Twitch sending out part.
Oh.
There is some. So now starting again. So let's see. It's connecting again. So no. So should so. Can anybody hear us again? Let's see.
I think we should be talking, right?
Yeah, I can. So there is. Let's,
Okay, so I think we're kind of good to go.
so how bad is the delay between audio and good audio and is somehow is against this thing. Normally there's only a delay between 1 to 2 seconds between audio and video, but this time it was up to a minute. So
let's see. I'm delayed. I hope I'm not delayed.
Should not be more than 1 second or something. Yeah, that's the 1 second.
Whew.
Second is Skype NDI stuff. I have sync in it locally, but the stream is audio 1 second later, and I did not yet found out how to solve this. But good, looks like it's working. So let's continue.
Okay, so I think we can resume, right? I really hope that I'm not with my voice delaying for 1 minute again. Okay, so I think let's see if I find my idea. Okay, so where were I? Here, I was trying to show you how you can implement a service that is on gRPC, and I will have a complex demo, but we need to start from the beginning. So a service is something that you inherit from the base that is automatically generated for you. And this service is nothing that a regular service that you would do in web API, right? You'll have the ability to inject whatever dependencies you need in here, loggers, other services, context repositories, or whatever. But it will work. Simple service, nothing special about it. The special part is when you implement the methods that you are defining in interface. And for example, we need to implement the say hello part that, as we already know in the proto file, it has one input of type hello requests. And you'll need to do something with that. It's up to you what you do. It's the business logic in there. And you'll notice in absolutely every other type of method, it's something called server call context that will give you access to the context. It's like HTTP context that we currently know and also work with. So it will give you the current context of the call. Okay, so this is pretty much how it looks. So this is the base part. But now moving on to the, let's say, more complex example where we have everything. We're using the same, pretty much the same approach, but I will show you in here the 4 types of that are available in gRPC. Come on, Zoom. So I have like that, a server that exposes the implementation, and 4 client apps, console apps that will expose the 4 types of in gRPC. So you'll have the unary, which is the request response, the classical one, server streaming, client streaming, and bi-directional. These 4 projects are the clients of this server, right? So being the clients, it means that they have some special capabilities. And I will show you something. If in HTTP clients, you are passing references, I'm going to show you the references that we have in these console apps. Let's see. It's a console app that is independent, and it has Google Protobuf, gRPC, and gRPC tool. It doesn't matter the version here. You'll need these packages in order to work with console apps. But where are the dependencies? Where are the NuGet packages that allow me to access the server? Well, there aren't. So the one common thing in here, it will be the proto file. And how you'll do that? So if we were to look at the project file for one of these clients, you'll see here that they have something that is, let's call it special. And that special thing is one item group that you will need to add by hand with this node protobuf and an attribute that is called gRPC services of type client. What you'll have to do here is to go and navigate and point out to the grid proto file. And in this case, the grid proto file, it's on the server side, is there in the server project. Of course, it can be can sit at the top level of your project or somewhere else. You just need to make sure that all your clients have access in terms of the path for this proto file. So if we were to look at the server part, you'll see that there is something different, and that different part, it's still an item group, and the attribute for it is gRPC services, but this time is the server part, not client as it was in the Unary project, and includes the grid proto file. And that's it. This is the common ground between them. No package sharing, no code references, no nothing. So the grid proto file, for us, it allows us to have 4 methods. The simple one that we're just demo but don't have a look at, and the 3 other types, okay? So how would these look? First of all, we have the greeter service inherited from the base that is generated for us. We have an iLogger injected. We have the say hello part that we already know. But let's look at the, let's say, specificity for each one. And first, I'm going to start with the server streaming. And we're going to look at the signature of this method. And the server streaming, besides the name, it receives an input. So one input, because we do not have the stream keyword between the type of here. We have in a hello request type. And we have the server context that I mentioned that you'll have with absolutely each type of request. And another thing, you'll have a iStream write-off of your type of T here. So which means that one thing in, several outs from the server. And what it does is very complicated logic with a lot of computation, is to have a loop, a for loop that goes from 0 to this number and issues hello and I as a reply, and simply just writes it to the stream. And that's it. So let's demo it a bit. So first of all, we need to have the server running, because there is the same thing as in HTTP client, the temporal coupling. So we will run the server app. So it will be up somewhere. And we will have the server streaming on the right-hand side. So you'll have a look here that on port 5001, it listens and awaits requests. And from the right-hand side, I'm going to start the server streaming client with the code that I just showed you. And you'll see that we're seeing some outputs. And the output goes to the number that the max value of I in that loop. And it says, hey, hello, I. And the I is increased by 1. So on the server side, we'll see that there is a special thing happening. So you'll see that we have an HTTP2 it's a post request, because for absolutely each method call in gRPC, we're doing a post request, not a get, not a put, not a delete, but post each and every time. And we have a path, greeter, and you'll see here that it's pretty much, I'm going to minimize this a bit just to add it in the same line. You'll have localhost, the port, the greeter service, and then the method that we're calling. So it's not like an API / my call API / endpoint and so on. It's something that's similar with the method. And in terms of MIME type, you're having application gRPC, and it returns a status code of 200. It's classical from HTTP2. And also, you see here how long it took, because this is the info that we're logging in. But in the client part, you'll see that the client is the one that initiates the request, and it gets a lot of pieces back. It's cool for streaming. For example, you initiate the request, and then it's streaming pieces of information. And another thing that is very cool about gRPC somehow is that you do not have headers, as in the traditional way of headers. You have something that is called trailer, that is key value pair mimicking headers. I'm gonna have a look at this just a second. Okay, so if you want to add something that is lookalike with a header, you need to go ahead in your method to add something like that, metadata entry, where you will specify the key and the value for it. And in terms, you will add this to the collection of, in the context, called response trailers. And you can add as many of these as you need. And if you were talking about authorization, for example, you'll have the same approach of adding the token. For example, you have the metadata, but you'll have the key authorization with the bearer and the token that you were generated somehow. Or if you want to decode that, it's in the same thing. You're reading from the fake headers part. So this is with the clients, the server streaming. I'm going to close this out, and using the same approach, server open, and we have the client streaming, and we're going to run the client streaming. And you'll see that we're pushing this time a lot of eyes. You see you get requests with quote unquote on the left hand side. So the server is still getting things from the client, while the client has no output, no response. And we're gonna wait. I hope I didn't add infinite in there. Okay, so it's done. So it got 9,9999, right? This number, and the client, as a response, it gets the last I that is passed to the server. It's the same approach. You see, it's very cool. For example, when you upload things, how cool you would be to just split a chunk of data into pieces and to upload it on the same request in the same channel somehow. Okay, so let's have a look at that method on the server, client streaming. The difference is that in this time, we are streaming or inputting a stream of hello requests. It's an async stream reader, and the server context is still there. And what we're doing is just to, I don't know, write. And as long as we have something to read, we're going to move next, and we're going to read from the request that incomes, and we're going to get the reply as soon as it's finished. And in the bi-directional part, it's a combination of those two. You have a stream of requests and a stream of replies, responses. And as the third parameter, you'll have the same context in there. Okay, so what you do is just awaiting and replying. So while you have things in the request stream, you're accessing the current stream. See, this is very similar to HTTP requests. And then you're going to write that thing in the response. So very easy, very basics in terms of bi-directional communication. So let's have also a look at that. Client streaming. And here should be the bi-directional part. you'll see that I'm sending 10 things and I get back 10 things. So it's very neat, right? But remember, if we were to compare this with Singular, well, still the client will be the one that will initiate the communication. So you cannot just push things from the server without the client opening the channel for you. So one thing that we didn't have a look at is the part where the client, right? So we're gonna pick one, and we're gonna pick server streaming, for example. And I'm gonna show you how it looks, how it is to initiate a request from a client to the gRPC server. So first of all, I'm gonna show you this, because this part is it's basically the core of the gRPC communication. It works with channels. If you ever work with RabbitMQ, maybe you have the concept of channels in there. You specify the local host or the path for the server, and here you specify the credential, if any. And in our case, we're going insecure because why not? And another thing is that you'll have already for you something that is called a client. So the greeter client, we didn't code, it was automatically generated for us. And the greeter client will have the channel passed in. And using that client, as we do in HTTP requests, the classical way with clients, we just take the client, call the method, bam, done, right? So this is what we're doing here. For example, we have the client, and then we have the server stream, which is our method that it's specified in the protocol. We're sending a hello request with also a cancellation token if you want. You have several ways of aborting such kind of a call, or I don't know, making it die after a certain period of time. What we do here is just awaiting from the streaming call, reading from the response stream, as long as we have a valid token, and just writing it to the console. And if we want to access the fake headers, we can access it from the call. You have this get trailers, and then as a dictionary it is, you will get the value from that and write from the console. Another thing that is somehow confusing is that you'll have status codes and exceptions, and you'll have an RPC exception, but you'll have different status codes. The status codes that go with gRPC are not the 63 of them in HTTP the classical way. These are more communication related somehow. We do not have things like I'm a teapot as a status code, but we have things like aborted, canceled, data loss, not found, out of range, permission denied, unauthenticated, and whatever. And you'll see they have a different numeric representation behind the scenes. So, for example, you can exceed the deadline if needed. You can pass, for example, I'm going to decode this. You can pass the deadline. So you can initiate a call with the server stream and pass a parameter called the deadline. So if you do not get anything back in that specified deadline, you'll just error it out and catch this in the exception, because that's what it's thrown in. So far it's very powerful because it's way faster, and we kind of need to have a look at the strengths, and we need to compare it with REST. I did this on purpose because people are comparing gRPC with WCF, which is, well, true, but I'm saying that if you're not doing REST the proper way, have a look at RPC because it has several benefits. And if we were to look at this two in the mirror, REST is resource focused and RPC is action based. It's code based and it's familiar to developers. And REST embraces HTTP semantics. It should use absolutely every, I don't know, necessary status code, everything that's in there, MIME types, and so on. Whilst RPC kind of embraces programming semantics. It uses behind the scenes HTTP2 because of the way it goes with it, but it's programmable, it's code related somehow. And REST, it gives you a loose coupling where it kind of meant to be like that. But in RPC, you'll have somehow a tighter coupling because you'll still have that temporal coupling. You still need to have your server app in order to respond to requests, and you'll still have the protocol that will pass around. It's not that independence that REST promotes. REST is text-based, and it's very understandable. You can have a postman call, you can decode that, while RPC is binary-based, and you cannot use postman to make a call and decode that and say, hey, I know why it doesn't work, because what you'll see is binary. And if you understand binary, good for you, but I don't think a lot of people will do. Right now, in our server and the client, no matter what the client is, you'll have the gRPC stub, the proto file, that will bring you a lot of power and also responsibility. If you were to look at the performance of the code, it kind of looks like this. gRPC payload for the same entity kind of looks 80%, 98 smaller than REST textual representation, which I think is huge when you have an environment where you need to take care of your client, what data you're passing through, and so on. And in modern times, you kind of need to have a look at your clients. Polyglot environment is perfect for that. You can have, I don't know, a .NET communicating with a C++. You can do that by having a proto file, not only JSON based, and it will be fast. It's super lightweight because of the binary, the serialization protocol, and the way it goes. It's lightweight, and it's very useful. For example, in mobile apps, would be very nice. But in fact, it's very. It tends to be the perfect way of point-to-point communication. I also have a talk where I'm talking about how to use microservices and what is the communication, the proper way of doing microservice to microservice communication. So point-to-point. In that case, it's messaging. But in our case, instead of using HTTP clients, you kind of should use gRPC because it's way familiar. And it's one point to another point. It's one-to-one. Also, being contract-based, it will allow you to forward version or backward compatible, make your API backward compatible just by changing the proto file and the implementation. And that's it. You won't break the consuming parts. Smaller payload, HTTP2, and of course, the different streaming types that can serve different business purposes. Of course, as like any other technology, it's not perfect. It also have the downsides, and we also need to have a look at those. Temporal coupling, it's not like in messaging where you can communicate and not have the temporal coupling. In here, both systems need to be up in order to communicate. And another thing is that looking so cool, you might forget that there's a network involved and you might tend to abuse the network. Also, it's not human readable, so not so easy to debug and understand what's happening. And it will force you to have a better testing and focus on the CI/CD part. It will force you to have a way of distributing the proto file between your consuming parties, whether being, I don't know, a deploy part or common location or whatever. You'll need to focus on CI/CD. And well, I think there are a lot of pluses and not a lot of downsides, and maybe it worth to try. So in summary, it has 4 methods, decouples code. In some way, you won't have nugget package sharing, and it allows you to have polyglot environments. But we also need to have in mind that maybe the future of web APIs will be something that is no more hunting for documentation. If you're talking to server calls, you won't have to get Swagger files, and we will not misinterpret HTTP status codes. And in here, I could add something like bad requests versus unprocessable entity that is currently happening. And also, there will be no more data parsed error. It tends to happen. So bear in mind that gRPC are just another tool in our tool belt, and distributed systems are all about trade-offs. There are no tools out there that will be suitable for absolutely every business. You need to look at your specific problem and decide if it's the right tool for you. But still, if you're not doing REST properly between service to service, maybe you should have a look at a gRPC. It has a lot of benefits. It's way too performant, and give it a try. And as next steps, have a look at gRPC Web. It's very performant, and it will allow browser to server communication. HTTP2 as how it is formed, how it's done. And also, if you want to know more about the syntax of protofile, you can go ahead and look at developers.google.com. And if you love to curl or you're using curl as a tool to make requests, maybe you can have a look at gRPC curl. There is an open source initiative that is very cool. It gives you gRPC requests from the console. And least but not last, gRPC for WCF developers. If you're interested in more, let's say, advanced topics like authentication and so on, Mark Randall did a great job in here. It has a lot of code example to get you started with a new technology. So thank you for listening. I hope it was useful, and I'm not delaying for 1 minute in terms of sound. If you have questions, please go ahead and write them in the chat.
We had some questions, Irina, during the talk. So the first question was, how can you consume gRPC services in ASP.NET Core MVC project?
And it depends. You should have a higher version of a .NET. I mean, and it's there for from 3.1, I think, and that's the minimal that you should have. So how you can consume? It's very easy. Just go ahead and add the packages that I showed you. Google Protobuf, gRPC, and gRPC tools. And basically, I have the console apps as clients. You will have the ASP MVC as the client. And what you'll do, it will, I don't know, just instantiate. Let me show opening. I don't know if I'm still showing my screen.
Yes,
but
yes.
But you'll basically do something like that. And here it will be the server where you're calling, and the rest is just easy. It's like you do it with HTTP clients. Is the same approach pretty much.
Good, thank you for that. So the second question we got is, the person said, thinks it could also be compared to remote method invocations. Could you briefly tell us about any tooling to help with testing of these remote method invocations?
First of all, I think it's gRPC tools, but curl, the tool that I mentioned on the summary. Here, gRPC curl, and you're basically parsing a response, and that response is binary format that you will be able to debug. In terms of testing, there's still not a lot of things out there for gRPC because it's pretty new. I'm sure the community will contribute and have a lot of things.
So no SOAP UI for
No SOAP UI,
gRPC
no.
yet.
But we still can use Postman to make the calls, but I don't know how to decode the answer because it's binary. Because it's a post request, it's at an endpoint, in fact, and also it has a MIME type that comes along with the request. So that's it. But the response, well, that's another story. I do not know yet.
Okay. Good. And that was the two questions I saw in the chat. Chat, you have now the chance to ask additional questions. So let's see how long the delay is. Good. Looks that there are no further questions there. So, Irina, thank you for giving the talk to us. Um, every speaker. Ah, there is one.
There is
There is
another
no
question.
another question. Okay, is there a way to provide a contract as an endpoint like Swagger or WSDL?
Not currently. Because it's somehow it intends to be like programmatic and for developers, not for tester or other types of humans that don't understand code. That's the purpose of it.
Because you
To
get
be
this,
honest,
you get this
I'm not
API.
missing the WSDL files.
I think nobody is missing it. Good. Yeah. Thanks, Irina, for the talk. Every speaker at our meetup gets a. I hope you can see this on the camera.
Yeah,
It's a
that's very
custom
cool.
custom
That's very
poster
cool.
with our logo, and I will send this to you if postal service is working to you. At the moment, there are some countries blocked, but I will get this to you somehow.
Thank you.
And yeah, thank you all for joining and watching despite the technical difficulties. We will figure out something for the next time. And yeah, thanks again to our sponsors, OGS Software and Services, Tieto Every and Rubicon, and JetBrains for the license. If you have a company and you want to sponsor us, get in touch with us. We have some sponsoring informations on our website. There are all suggestions. Please simply get in contact with us and we find a solution. Next meetups. So we have a lot of stuff planned already. In April, end of April 27th, we have machine learning for .NET developers by Veronica. May we're working on the latest details. Let's see. Should be announced soon. In June, we will do our Microsoft Build After Conference talk show like last year. And in July, we got Brandon Minnick from Microsoft to tell us something about .NET MAUI. So a lot of talks already scheduled. April is already on meetup.com. So register that you don't miss it. If you want to hear something about some topic, please use our issue tracker for that and create issues there, and we will try to find a speaker for the topic. And yeah, please spread the word that we're doing these meetups, invite colleagues, friends, customers to the next one, retweet our stuff, and yeah, invite everybody you know in the .NET world. Quick reminder, stuff links again to our homepage, Twitter, Twitch, YouTube recordings and Slack channels. All the audio problems shouldn't be in the recording because we're doing this locally. So there should be everything fine and should go up in the next days. And last thing is we want to always improve our meetups. And for that we would need your feedback. I share this link with you. It's a quick feedback form. If you could fill it out, it would be wonderful. And at the end you can say if you want to take part in the raffle of the JetBrains license. And we will draw somebody at the weekend and send them the license to it. Yeah. Thanks again for joining. Thanks again, Irina, to you for taking your time and giving us the talk. And I hope we see us on April 27. Have a nice evening. Have a nice rest of the day, depending on where you are. I think we got some views from Oklahoma, I saw in the chat. So enjoy the rest of your day. And yeah, see you next time. Bye.